So, a group of physicists just claim to have proved we don't live in a computer simulation. And they say it's all tied up with Roger Penrose's ideas about quantum physics and consciousness. Now, Penrose has this theory. He thinks consciousness isn't computational. It's not an algorithm. He and anesthesiologist Stuart Hameroff propose that it's rooted in a quantum process happening inside the microtubules of our brain cells. They call it orchestrated objective reduction. The idea is that this quantum phenomenon is non-algorithmic, which is why a classical computer could never truly replicate consciousness. Then you have someone like Michio Kaku.
The point I'm raising is no computer is powerful enough to do that computation of a butterfly's wings that could set off a storm. Is it possible? Yes. Is it computable? Probably not. So in other words, chances are we do not live in a computer simulation.
Who takes the simulation idea seriously. He's talked about our universe potentially being a digital simulation, though he's also pointed out that simulating the entire universe is probably impossible. No computer is powerful enough. But maybe parts of it could be simulated. Or maybe the universe is made of pure information. It all sounds fascinating, but let's break it down. To our best knowledge, everything in the universe is made of particles from the Standard Model, held together by four fundamental forces. We describe it all with math, equations. And equations can be put on a computer. An algorithm can calculate what those equations do, which naturally leads to a question. What if our entire universe is just a computation run by some advanced species? What if we're just part of the algorithm? That's the simulation hypothesis. Philosopher Nick Bostrom even argues that the odds are we're more likely to be the simulated than the simulators. But the huge problem with this idea is, how could you ever possibly prove it wrong? Well, this new paper claims to have an answer. The authors say we can't be in a simulation because of Gödel's theorem. Gödel's incompleteness theorems are a mind-bender from math. Basically, in any consistent formal system complex enough to describe arithmetic, there will always be true statements that are unprovable within that system. Mathematical truth is bigger than what can be formally proven. Here's their argument. Any theory that describes our universe is complex enough for Gödel's theorem to apply. So there will be truths about our universe that the theory itself cannot prove. That's just math so far. But then they argue that we humans could, in principle, go out and observe these truths. We could settle these unprovable statements by making a measurement. They give examples, like the detailed properties of what happens inside a black hole. The physics might be so complex that our theories can't compute it, but we could, in theory, measure what comes out when the black hole evaporates. There are other proposed examples in physics where an observable quantity is provably uncomputable, meaning no algorithm could ever calculate it in a finite amount of time. So, the authors say, Gödel tells us there are physical truths we can't prove, but we could go and measure them. Therefore, humans can do something the math alone can't predict. Consequently, we can't be computed by an algorithm, and the universe can't be a computer simulation. This is eerily similar to Penrose's argument for why human thought isn't computational. He says that since we can understand Gödel's theorem, our cognition must be more than just computation. He thinks that something special, like the collapse of the wave function, is where consciousness and this uncomputable element come from. So, what are we to make of this? It sounds like a really clever argument. Unfortunately, it assumes its major premise. We have never actually measured any quantity that is provably uncomputable. To assume that we can is logically the same as just assuming we don't live in a simulation from the get-go. Think about it. In the real physical world, can we actually measure? No. Isn't that weird? It's like we actually can't measure anything an algorithm couldn't also compute. So, maybe we don't live in a simulation. Or do we? What do you think? Does their theory make sense? Or is it just the wrong way to interpret reality? Let us know in the comments. And as always, don't forget to like and subscribe to Brainwave. Until the next time, take care.